All right, for this section, we're talking about exponential growth and decay, separable differential equation. And the definition says a differential equation of the form of dy over dx is equal to f of y times g of x is called separable. What we're going to do, what it means is we're going to separate and put the variable on one side of the equal sign and put the x variable on the other side of the equal sign. And the solution is found by anti-differentiation or by integration. We're going to integrate each side with respect to each variable, whether it's x or y. So if you look at example 1, it says solving by separation of variable. Solve for y if dy dx is equal to xy in parentheses square. Then we're going to do some evaluation here. So how do I start with this one? I'm going to go to the next page and start. So this is what they gave me. They gave me dy over dx is equal to xy squared. And the question is to solve for y. So I have a dy dx equal, I'm going to get rid of the parentheses. So that's x squared y squared. Now I need to separate the variables, bring the x's to one side, bring the y's to the other side. Since I already have the dy here on the top, I'm going to divide by the y squared. That means I'm going to multiply up with the dx. It's like cross multiplying. So this is what I have. Dy over y squared is equal to x squared dx. So now I need to take the integral on both sides. And I'm going to go ahead and bring this one up. You know exactly what I'm doing right here. Okay, so now I'm going to do my integration. So this is y to the negative 1 over negative 1 is equal to x to the 3 over 3. Of course, there's a plus c. Okay, so now we're going to apply the initial conditions. Which was on the other page, y equal 1, x equal 1. So I'm going to go over here, I'll plug in for y. So I have a negative parentheses, negative 1 to the negative 1 equal 1 to the third power over 3 plus c. So what I have here is a negative 1 equal 1/3 plus c. That's going to give me a c of negative 4 over 3. Now I'm going to rewrite my equation with the c in it. This one I'm going to write as negative 1 over y, that's this, is equal to, where am I? We go back to the x cubed over 3, and c is a minus 4 over 3. But remember, we're solving for y, so I'm going to leave this one alone for a second. I'm going to do a common denominator over here. That will give me x cubed minus 4. Okay? So what I have here, I'm going to cross multiply. I have y parentheses x to the 3 minus 4 is equal to negative 3. I'm going to divide through. So I have y equal negative 3 over x to the 3 minus 4. And that's the answer. If you want to check if this is right, well, they gave you what dy dx is, right? So find the derivative dy dx and see if you get this. Okay. Another example with separation of variable with initial problems, initial value problem. So this time I'm given dy over dx is equal to x over y. Initial conditions y equal to x equal 1. So right here, I'm going to do the separation of variables. Looks like I can cross multiply. I'm going to get y dy is equal to x dx. So once you separate the variables, you need to do the integration on both sides. So the integral of y dy is y squared over 2 is equal to x squared over 2 plus c. Apply the initial condition when y equal to x equal 1. So here we have a 2 squared over 2 is equal to 1 squared over 2 plus c. That's going to give you a c of 3 over 2. Rewrite your equation. So I have y squared right here. Y squared over 2 is equal to x squared over 2 plus 3 over 2. And we're going to solve for y. Okay, we can do a common denominator here first, if you like. Y squared over 2 is equal to x squared plus 3 over 2. Solve for y, so y squared is equal to x squared plus 3 over 2 times this 2, which is going to cancel. So what I have here is y equal to the square root of x squared plus 3. Oh, there we go. Sorry. I'm going to do another example. Same question. Use separation of variable to find what y is. For this one, I'm given dy dx is equal to cosine square of y, and we're given the initial conditions. So separate the variables. It looks like what I need to do here, I'm going to end up with dy over cosine square of y equal to dx. Well, then once you separate the variable, you integrate. So I have dy over cosine square y is equal to the integral of dx. Well, this one here is 1 over cosine square, which is a secant square. And just by recognizing that, it makes it so much easier because we know what the integral of a secant square is. That's a tangent. So that's a tangent y, and the integral of 1 dx is x plus c. Okay? So once you do your integration, you always apply the initial conditions. So I have a tangent of 0 is equal to 0 plus c, and that's going to give me c equals 0. Rewrite your equation. So we have a tangent of y is equal to x plus 0, which is x. So remember, I'm solving for y. If I have a tangent y equals something, y is equal to the tangent inverse of x. And that's the answer. Okay? Just remember this step here. I'm going to do one more example for you. This time I'm given dy dx is equal to e to the x minus y with the initial condition y equal to x equals 0. So we're going to do separation of variables. So I notice right here, I can separate this. This is e to the x times e to the negative y. Same base, you add the exponent, but we're doing it backward. So now I can separate the variables. I'm going to get dy over e to the negative y equal e to the x dx. Cross multiply. Now I'm going to take the integral. I'll bring this one up. This is e to the y dy equal the integral of e to the x dx. Well, the integral of e to the y dy is e to the y, and the e to the x is e to the x plus c. Once you integrate, you apply the condition, the initial condition, in this case, y equal 2, x equals 0. So I have e to the 2 is equal to e to the 0 plus c. E to the 0 is 1, so c is equal e to the 2. Just leave it as e to the 2. You don't need to, wait a minute, that's a 1. That's a 1. I went a little too fast. 1 plus c. So c is e to the 2 minus 1. Okay? So now we go back. We have e to the y equal e to the x plus c, which is plus e to the 2 minus 1. I'm looking for y, remember? And y is a power on an exponential function. So to solve for y, I'm going to have to take the natural log on both sides. Natural log of e to the y equal natural log of e to the x plus e to the 2 minus 1. When you take the natural log of e, that will release this y down. You can use that rule with the power. Y then e is equal to natural log of e to the x plus e to the 2 minus 1. Natural log of e is 1, so you have y equal to the natural log of e to the x plus e to the 2 minus 1, whatever that number is. Okay?